Alright, so this video is a quick overview of my business analytics final project on predicting movie success with the IMDb dataset. So here's just a quick overview of the data. The data mainly consisted of general movie information, such as color, the director, and the genres, that kind of stuff, and then also the reviews of the movie, the critic reviews, the user reviews, Facebook likes, and so forth. So the first part of the project was for business understanding. To start out with, I did correlation analysis to be able to determine which variables were highly significant to the IMDb score, which again in this case was being used to predict movie success. So after doing a quick correlation analysis, the top 5 variables that were highly correlated were number of voted users, number of critic reviews, number of user reviews, the duration of the movie, and the number of Facebook likes. So the second part was data understanding, taking a quick look at the data, finding any data quality issues that might be present. So after doing my analysis on that, I found that there appeared to be multiple null values and missing values through many columns of the data set. There also appeared to be columns that were not necessarily important to predicting IMDb score, or that was not as significant as other variables, so they could probably be removed to shorten up the length of the data set on the column-wise. And then the genres column also had many multiple values in one cell. So being able to take just the first genre of each movie and making it the main genre of the movie would be easier for analysis later on. And then there also looked to be multiple movie duplicates throughout the data set. So the third part was data preparation, taking those data quality issues and preparing and fixing them and cleaning the data set. So for my data cleaning processing, the methods I took were I removed columns that were not significant to IMDb score to be able to handle the null values. A lot of the columns that weren't necessarily significant had a lot of missing values, so getting rid of the column just got rid of the null values. I removed the title duplicates throughout the data set. I split and separated the genre column and just created one column that had the main genre, which was the first genre from the other column. And then I created 2 new columns that calculated the profit of each movie, and then another column based off of that profit column if it was a profit or a loss. So the fourth part was business intelligence. This was the bulk of the project with data analysis and visualization. So first I did some quick number analysis on movies. I found that the average budget of movies was around $41.5 million. The average gross was $50.2 million. Profit was $8.7 million. The average duration of movies was 110 minutes, or an hour and 50 minutes. And then the average IMDb score of all the movies was around 6.5. From that, I was able to basically say that movies usually grow, on average, movies gross more than the budget, and most movies do make a profit. Alright, and the next part was doing more data analysis. This time I used group by to be able to dig deeper into it. So doing the group by, I found some other interesting information about the data. The top movie genres were comedy, action, drama, adventure, and crime. The majority of the movies were filmed in color, with 3,641 of them and only 127 black and white. Most likely just due because most of the movies that were filmed in black and white were probably much older than currently. Top languages for movies were English with 3,590, and then French and Spanish coming in second and third with relatively low numbers. The top 3 countries for movies were USA, UK, and France. Top 4 content ratings were R, PG-13, PG, and G. And then the top 2 aspect ratios were 2.35 and 1.85. So the next part was correlation analysis and being able to really see which variables really did correlate with IMDb score. And so here was the quick correlation heat map again, showing all the correlation with IMDb score. And then these next 5 slides are the correlation visuals and Seaborn and relationship between IMDb score and those top 5 variables. So here we have IMDb score to the relationship of number of voted users, and you can see as number of voted users goes up, IMDb score goes up. Number of critic for reviews, number of users for reviews, the duration of the movie, and maybe Facebook likes. So as you can see on all those, usually as those increase, so did the IMDb score. So again, those were the 5 highly correlated variables to IMDb score, number of voted users, critic reviews, user reviews, duration, and Facebook likes. I did do other correlation and visuals with other variables. The only other variable that was somewhat close, but I was a little surprised that it still wasn't as high, was the budget. But there were other variables that were positively correlated, but just not a huge influence as these top 5 here. So the next part was model and evaluation. This is where I did build my regression models, classification models, and clustering models. So to start off with, we did regression model. I did regression model. The models I built were regular regression model, the random forest model, and a ridge regression model. Out of those 3, the random forest regression model was my top model with the best accuracy. As you can see, the variance R-squared was 0.93, so 93% accuracy with a mean squared error of 0.069. And again, that was my highest model built with the highest accuracy at 93%. And then with that, the top 3 variables by random forest regressor that were significant were number of voted users, duration, and budget. So budget cracked the top 5 there on the random forest, which didn't surprise me because budget, usually when people see that a movie is going to be largely, it's going to have a lot of money budgeted for it, that usually means better actors, better technology and stuff used for it. So a lot of people usually consider that a better product or better movie than others. The next model was classification analysis. The models I built were decision tree model, k-nearest neighbor, and random forest classifier. Out of those 3, my k-nearest neighbor model was the highest in accuracy, and here's that. Showed a 68% accuracy, so not the greatest, but it was still the highest that I could get for classification. The last model building was clustering analysis. After doing clustering analysis, or breaking it down to 2 clusters, and going through, I found that the top variable, the variables were, the top significant variables were similar to the original variables that was highly correlated to them, and the only difference was that duration took the top spot. And we can see that here, duration became the most significant variable to IMDb score. Alright, so there were my models, and then, so final storytelling, again, just to kind of sum that up. So I did a quick analysis on just some basic budgeting stuff for the budget, the profits, the duration, and IMDb scores of movies. Also found top genres, the languages, countries, content ratings, aspect ratios. And again, those top 5 highly correlated variables looked pretty, or seemed to be pretty consistent from the correlation from the beginning of my analysis, and then also into my model building. The number of voted users, the critic reviews, the user reviews, the duration, and the Facebook likes. And you can see out of those 5, with the exception of duration, they all kind of cluster together in that they're all alike. They're all related to reviews, votes, Facebook likes, and reviews. So with that said, those are my top 5. Those were the top 5 highly correlated. And if I was presenting to the movie industry and trying to give them a recommendation on what to use to be able to predict movies, I came to the conclusion that early reviews of movies are very important to pay attention to. This is not surprising because many people want to see if it is worth the time and money to go see the movie. Just like if they want to go buy a product or if they want to go use a service, people want to look at reviews and see if they're good or bad and whether it's worth their time and money to go do it. Same thing with movies. They want to see if it's worth their time and money to go see it, if it's going to be good or if it's going to be bad. So when it comes to predicting how well a movie will do, the industry should really pay close attention to early reviews of the movies from critics, from early moviegoers, and posts and comments on social media to determine how well the early days of the release are going for the movie. Knowing that can help decide if more or less money needs to be spent on advertising, if the time duration from the movie being in theaters needs to be increased or shortened, whether it's making money or not, or if it's projected to do good, and being able to, even afterwards, after the theater, to be able to tell how many DVD or Blu-ray discs to produce. So in conclusion, again, I think it's very important to pay attention to the reviews from critics and users and stuff from the beginning, early on of the movie being released, because those are good indicators of whether other people reading those reviews are most likely going to go see the movie or not. And that is my wrap-up.